Hello everybody, we're going to be simplifying fractions like the Dark Knight. Not really, but whatever. Moving on. If we move on from here, for the most part, all you need to know about simplifying fractions is you just have to be able to factor and cancel. So just making sure my pen's going to work. As long as you know how to factor and cancel, you know. So now, mind you, this is a fraction right here. So the way we're going to actually simplify this, so your directions on this will just be to simplify. The way that we'll simplify this is we're factor and cancel. First thing, you factor the numerators, factor the denominators. If you factor the numerator, you're going to end up with 3 times x plus 2. In the denominator, you can factor out a 3. You'll end up with x plus y, right? And since you have a 3 and a 3 here, you can cross out those 3's, and what you're left with is x plus 2 over x plus y. And it is fully simplified. However, you are not finished. Not only that, but you have to figure out what are the points where this expression is not defined. So you have to tell me what x cannot equal in this case. Here you'll have that x cannot equal negative y. So you have to give the restrictions to this actual polynomial, because if x equals negative y, then imagine it here that x equals negative y. We'll have negative y plus 2 over negative y plus y, which will give you negative y plus 2 over 0. And you can't have a 0 in your denominator. So that's why your restrictions on this, will be x cannot equal negative y. All right, let's do another one, just so we are on the right track with this. All right, you get another rational expression that looks like this. And first things first, you factor. So if we factored this, it would look like x plus 3, x minus 3. That's going to be my numerator because I factored x squared minus 9. And then in my denominator, well, I can't factor those. Those are two primes right there. So we'll just rewrite it. So 2x plus 1 and 3 plus x. Now, you might look at this and not see any not see any common factors. However, there are. Just because the terms are rearranged inside the parentheses doesn't mean they're the same thing. If you look closely, x plus 3 equals 3 plus x. So if you need to, you can rewrite it just so you have them in order. So I rewrite my numerator, rewrite my denominator. Hold on one second. I didn't mean to do that, and I didn't mean to do this. So rewrite the denominator to be, instead of 3 plus x, you can write x plus 3. And now you have common factors. You have x plus 3 on the top, x plus 3 on the bottom. So since you have those, you can cross those out. Why? Because x plus 3 over x plus 3 would just be 1, wouldn't it? So what you'd be left with is x minus 3 over 2x plus 1. Now, after this, you have to say what your restrictions are. Now, what your restrictions in this case would be is if, in fact, your denominator is 0. So if your denominator is 0, you would have a restriction of x cannot equal 1/2. Some of you might want to just go ahead and set the denominator equal to 0 and solve it, because just in case it gets difficult. But here you say that x cannot equal 1/2. Also, x cannot equal negative 3. Does anyone see why? The reason why is because right here in the original fraction, if x equals -3 in the original fraction, then you're going to get a 0 in your denominator. Why? Because 3 plus -3 is going to be 0. This is going to multiply by this and become 0. The whole thing's going to become undefined. So make sure that you write all of your restrictions. Next, let's try this one right here. This should actually be fairly easy. It says solve for x. We're actually going to get a fraction out of this. First things first, if we're trying to solve this fraction, let's go ahead and put all the x terms on the same side. So if I put all the x terms on the same side, that means I'm subtracting bx from both sides. And I want to get everything else away, right? So if I want to get everything else away, so I subtract bx on both sides. Let's add a squared on both sides. So your new equation should look like ax minus bx equals a squared minus b squared. Now you see things, since we did polynomial equations, you see things that can be factored. So here I'll factor out an x. If I factor out an x from here, inside I'm left with a minus b. Over here I'm left with a plus b times a minus b. So after that, what if I divide this side by a minus b and divide this side by a minus b? That cancels. I'm left with x equals a plus b times a minus b over a minus b, right? So since that's what I'm left with, I can actually go even further from there and tell you, since it's, since it's fully factored, now I give my restrictions. I know what x equals, so give my restrictions. What cannot be what? In this case right here, we know that a cannot equal b. So that's the only, because if a equals b, then b minus b is going to be 0, and you have a 0 in your denominator, and that messes up everything. So for the most part, these are the kind of problems we're going to be doing, and I hope that this helps a little bit. In order to make sure that you guys watch this video, do these 3 problems, and I want you to put them on my desk. This will ensure that you guys watch the video. So make sure you do these 3 problems and put it on my desk before you leave today. It's 6th period, so this is what you should be doing anyway. So on top of, well, other than that, I'll see you guys later.